So let's continue with our lecture series on NEET PYQ. This is our last lecture on laws of motion, right? So let's do the remaining problems. Our first question says a car of mass m, okay, is moving on a level. So level is quite important. Circular track of radius r. Fine. So if it is a level circular track, theta will be 0 degree in that case, because here it is a simple circular track of radius r. If mu represents the static friction between the road and the tires of the car, the maximum allowed speed of the car in the circular track or circular motion will be how much? Okay, so maximum allowed speed, we have to find that. And if you remember our previous lecture, I have already given you this expression. Maximum allowed speed will be equals to under root rg. Okay, g is acceleration due to gravity in this case. Okay, here it will be mu plus tan theta, where mu is the coefficient of static friction between the tires and the road, whole divided by 1 minus mu tan theta. Clear it is? And if it is a level track, tan theta is tan 0 degree. And what will be tan 0 degree? Tan 0 degree is 0. Correct? So let's substitute here. Tan theta becomes 0. This also becomes 0. So what we left with is root under r g mu whole divided by this whole thing becomes 0 and whole divided by 1. So v will be equals to under root mu g r. That's our correct answer. So that is our option D, correct? Mu r g. I hope this is clear. Okay, let's move to our next question. Great. Our next problem says a car of mass 1000 kg. So mass here is 1000 kg negotiates a banked curve of radius r is how much? 90 meter, quite similar to the previous one, on frictionless. Now this time, if it is frictionless, this time what will be 0? Mu will be 0, right? So static coefficient of static friction will be 0 in this case. Okay, if the banking angle is theta is 45 degree, what we have to find? We have to find the speed of the car, right? So let me remind you with our expression. Our expression was nothing but root under rg mu plus tan theta whole divided by 1 minus mu tan theta, correct? Now what will be your theta here? Theta here is 45 degree and mu here is 0. Let's substitute the values. R, what is the R? R is 90 meters, okay, the radius of the curved path. G here, acceleration due to gravity 10, and mu is 0. 1045 is 1. Let me remind you, 1045 degree, theta is 45 degree, 1045 is 1 whole divided by 1 minus 0, correct, because mu is 0. So this will give you equals to under root 900, correct? And under root 900 is nothing but 30 meter per second. So correct answer here is 30 meter per second, option B. I hope this is clear. So our question says a gramophone record is revolving with an angular velocity of omega. A coin is placed at a distance r. Okay, so let me write here omega, and it is placed at a distance r from the center of the record. The static coefficient of friction is mu. The coin will revolve only if, what is the condition? Okay, let me explain you what is a gramophone. Gramophone is a music system of previous time. So basically it is like a plate. You can imagine if a plate is rotating and I place this pen and on anywhere on the plate, what will happen? This pen will be thrown out. Let me repeat again. If you take a plate, any plate, the plate on which you are eating food or something, if there is a plate and there is a motor fixed on it, and this plate is continuously rotating and you are placing the pen, all of a sudden what will happen? The pen will be thrown outward. Same thing happens if this is a gramophone record and you are placing a coin. This coin will have a natural tendency to go out, right? And what will be the force acting on this coin? The force acting on this coin will be centripetal force, which is Fc, that is equals to m v square by r, correct? And you can express it in terms of angular velocity as m omega square r square upon r, correct? Omega square r. I hope you are clear with this. Let me give you the expression here. V equals to omega r, correct? So if I substitute V equals to omega square r square upon r, one of the r will cancel. This is the centripetal force. This is the force with which the coin will be thrown out of this plate, right? If your friction stops this, is equal or greater than this particular force, this coin will stay there, right? So I will say that the force of friction must be greater than equal to m omega square by r, correct? And what is our frictional force? So mu times normal reaction, which is weight of this subject or the coin, m omega square r. Okay, let's cancel out this m with m and take this omega square on the left hand side. It will be equals to mu g upon omega square must be greater or equal to r, correct? Let's see which expression is true here. So mu g upon omega square is greater than r. Be very careful with option C and D. Okay, see here, look at the greater than equal to sign, that will help you a lot. So r is less than mu g by omega square, which satisfies option C. Let's see the next question. Next question says a 500 kg car, so mass of the car here is 500 kgs. Okay, fine, takes a round turn of radius 50 meters, so r is 50 meter, fine, with the velocity v is 36 kilometer per hour. Let me convert here straight away into meter per second, so this will be 10 meter per second, right? The centripetal force will be how much? We already know the centripetal force F is equals to mv square by r, correct? Let me substitute here values. M is nothing but 500. Velocity square, velocity is how much? 10. So 10 square is 100, whole divided by r, which is 50. Let's simplify it further. So this cancels with this, 5 cancels with this, will be 10, and you're left with 1000 Newton. That's our force. So option C is correct. Straight away, direct formula based problem, right? Let's move to the next question. Great. Our next question says a ball of mass. So what is the mass of the ball? 0.25 kg attached to the end of a string of length L equals to 1.96 meter is moving in a horizontal circle. Fine, it is moving in a horizontal circle, not the vertical one. The string will break if the tension is more than 25. So maximum allowed tension is 25 Newton. What is the maximum speed with which the ball can be moved? Okay, so obvious it is that you are given with a ball of mass this much and a string of length this much, and you are rotating it in horizontal circle, right? So on that horizontal circle there is a force which is mv square by r, centripetal force, and this must be equals to the tension. So 25 must be equals to m. What is m? 0.25. Velocity they are asking. R, what will be the radius of or the length? The length of the string is 1.96. Let's cross multiply it. So it will be 25 into 1.96 whole divided by 0.25 equals to v square. Let me simplify it. Let's remove this point and this point. Both will cancel out because there are two digits, okay, after the decimal point. So 25 will cancel out with 25. You left with v square will be equals to 196, and root of this will give us v equals to 14 meter per second. I hope there is any answer like 14 meter per second. Yes, option A. Clear? Let's see the next question. Great. Our next question says two racing cars, okay, of masses m and 4m, fine, m and 4m, are moving in circle of radius r and 2r. This is r, this is 2r, fine. If their speeds are such that each makes a complete circle in the same time, so time period is same, t1 equals to t2. The time taken for the first car is equal to time taken to cover the same lap, okay, for this one t2. Okay, t1 is the time period of this whole thing. Time period means you started with some position and you came back to the same position. Here also you started with some position, you came back to the same position. Okay, that is t2. So t1 and t2 are same. Then the ratio of their angular speed, be very careful, angular speed only depends on the time period. So 2 pi by t, correct? Doesn't care about these two variables. Okay, so what is important here, if the time period is same, the omega, the angular speed will be same. So this will be 1:1. I hope this is clear. Let's see the next one. Okay, this is our last problem on laws of motion. If you have not watched previous videos, okay, there are 4 more lectures. You can watch it. Playlist is in the description. We will start with work power energy in the next lecture. So let's see our last question. Last question for this chapter is, when milk is churned, cream gets separated due to centrifugal force, because this force throws out. It is an outward force in a uniform circular motion. Okay, so we'll continue with this lecture series.